A third example here is one where we're asked to factor what seems to be pretty simple, 4y squared minus 6. So of course we look for a greatest common factor first, and 2 divides into both of those terms, leaving us with 2y squared minus 3. Now that 2y squared minus 3 is not a difference of squares, so let's see if it's even factorable. The value of a is, of course, the number in front of the y squared. The value of b is the number in front of the y, and there is none, so b is 0. And the value of c is the constant, in this case, negative 3. So if I calculate b squared minus 4ac, I find that that comes out equal to 24. 24 is not a perfect square, because when you take its square root, you get a decimal. But the good news is we can keep going. No, we cannot factor this over the integers, but we can factor it over irrational coefficients. In other words, those that might have a square root in them. So I'll proceed just as I did previously when the discriminant was a perfect square. I'll use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now that square root 24 we know can be simplified. It has a perfect square of 4 that divides into it. It's 4 times 6. So the square root of 4 times the square root of 6 is the same as the square root of 24. But the square root of 4 is 2. So the square root of 24 simplifies to 2 square root 6. So what I now have is y equals positive and negative 2 square root 6 all over 4. That reduces. 2 over 4 is equal to 1 over 2. So I get positive and negative 1 square root 6 over 2. So you notice my factors are irrational, or my zeros are irrational, because I have a number under the radical that is not a perfect square. So to factor this, using the methods I showed you in the previous example, I'm going to have an x in each of them, or in this case it's a y. The denominator of the zeros becomes the coefficient of the y, and each of the zeros, positive and negative square root 6 over 2, has a denominator of 2. The opposite of the numerator then completes that binomial. So I'll have a 2y minus the square root of 6, and I'll have a 2y plus the square root of 6. Now just to verify that this does in fact equal the polynomial I began with, first times first would be 4y squared. Outside times outside would be 2y square root 6. Inside times inside, negative 2y square root 6, which cancel one another out. And last times last, negative square root 6 times square root 6 is negative square root 36, which is negative 6. So I do get the polynomial I started with. So my factors are 2y minus square root 6 and 2y plus square root 6. So in this final example, we ask you to solve this equation. And notice it's set equal to 0, which basically means that we are going to want to find its zeros. And we'd like to try to do this by factoring if possible. So we'll notice that the greatest common factor of all three of those terms is 6x. If I divide out 6x, 12x cubed divided by 6x is 2x squared. 18x squared divided by 6x is 3x. And 12x divided by 6x is 2. Now I want to continue to try to factor this, but I notice that what's in the parentheses is not a perfect square trinomial. So let's even see if it's factorable over the integers. B squared minus 4ac would be 3 squared minus 4 times 2 times 2, which equals negative 7. Well, of course, a negative number is not a perfect square. Therefore, it's not factorable over the integers, but it is a quadratic equation, so we can use the quadratic formula once again. So we'll get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we know that when you have a negative underneath a radical, that becomes an I out in front. So I get negative 3 plus or minus I square root 7 all over 4. Now this looks nasty, but it's not as nasty as it might seem. Those are the solutions, and they happen to be imaginary or complex solutions. If we did ask you to write the factors, what you would do is, again, just put an x with each of them, and then the opposite sign. And with imaginary or complex zeros like this, the opposite sign would be x minus that quantity, negative 3 plus I square root 7 all over 4, and x minus that quantity, and negative 3 minus I square root 7 all over 4. Now if I FOILed this, though, that would be nasty. But I notice right away, though, x times x is x squared. My leading term is 2x squared. So what that basically means is I need to put a 2 out in front. That's a good one. You're not going to encounter many of those. But our focus in this example was primarily to just find those zeros because the equation was set equal to 0. There they are in the blue box. So once again, we wanted to continue to factor polynomials, now not just over the integers and not just over the real numbers, but also complex numbers, and then find zeros by factoring. If you have any questions, don't hesitate to email me.